Well, welcome everyone. So this is the FHIR newbies crowd, right? So everybody is new to FHIR? Okay. We all know how to spell it though, right? Okay, good. So as Martes had said, I am Richard Ettema with Aegis, based in the United States. I've been working with FHIR now for about 4+ years, so I actually started back in the previous Q1 days with Connectathon 4. My boss basically said, hey, this FHIR thing looks interesting, we should go to the Connectathon. Build me a FHIR server. Okay, you've got about 3 weeks to do it. And ended up going to the FHIR Connectathon and doing the patient track, and I've never looked back. So I'm here today to give you a general introduction to FHIR, and we are going to explore the specification and take a look at some key aspects of the FHIR specification. So FHIR itself, as you probably all know by now, it's the latest HL7 standard for the exchange of health information. Defines a very simplified approach, or a more simplified approach, to implementing without sacrificing that information integrity. And one of the key concepts of FHIR is this definition of a resource, or resource type, and that's what we're going to take a look at for a bit here. But first, the acronym. You may know how to spell it, but what does the acronym actually mean? So F is for fast. That's for designing and to implement. Of course, that's relative. No technology can make us implement as fast as we'd really like. Health is, or H is for healthcare. That's why we're here. Interoperable, same. And resources. So the building blocks upon which FHIR defines what we're going to be doing. So in terms of resources, as I said, they're building blocks. They are the way that we put data together to put together those clinical concepts. So for example, we have things like a diagnostic report. Well, a diagnostic report doesn't live by itself. It's referencing a patient that goes along with it. Well, a patient itself may also have other related pieces of information, like a related person, family member. The diagnostic report is delivered or produced at a particular location. And there's probably one or more practitioners that are involved in that diagnostic report. So these are just some of the examples of the types of resources that you'll find in the FHIR specification. So from a definition perspective, resources are the logical common contents of the resource. They're mapped to formal definitions. If you're familiar with the RIM, you'll know that a lot of the elements, most if not all of them within FHIR, are mapped to some concept within the RIM. And they can be represented in multiple syntaxes. Out of the box, usually JSON and XML is the type of format that we think of, but recently added was support for Turtle, or that terse RDF tuple. We also have native support for extensions within the resource itself. So these are data elements that are not part of the core specification, that you may think of as extensions that a local, regional, or country might want to put onto a particular resource. Like a patient, you might want to track something like something beyond just birth date, maybe birth time, and so forth. So you have to do an extension with that as well. The key thing to remember here is that they are part of the specification. Extensions belong to the resource, and the definition of that extension is going to become part of the specification. So there are mechanisms within the spec to actually allow us to publish and manage what those extensions mean. Also, very important with the resource is human-readable content. And within the FHIR resource, you'll find a text area of the resource instance where you're going to find XHTML as the content, as that rendering of that data. So as an example, here's a patient resource rendered in XML. I like to use XML initially because it's a very structured way of putting the data out there. So you see the resource type is the root element up at the top, and then the various sections that you see are going to be the key portions here. So we have the resource ID. This is the unique FHIR resource ID for this instance of this resource type within the FHIR repository. Metadata for things like versioning, also the last updated, maybe the last user that did an update or modification. Profiles, tags, and so forth will go here. And then that textual portion comes next. So in here, this is where the XHTML is going to be rendered. So there's a div tag, and then inside that div, you have to have client XHTML to render that data. So the reason we do that, of course, is the rest of the content is all computable, but a lot of times we want to make sure that we get renderable data into the hands of the clinician. After that, if you have extensions that are part of the resource, they will appear next. So here, as I mentioned, you could have something like, instead of gender, you could have birth sex, depending upon what the requirements are for the region that you're in. That could be a value of a codable concept or a code or whatever the data type might be. Following that are going to be all of the common data elements that are part of the base specification for that resource, so the standard data content. So for the example, for a patient, we have the patient identifier, which is the clinical identifier for the patient as opposed to the resource ID for FHIR. And after that, of course, active, name, you could have address, and so forth. This is a simple example. Not everything that is possible within patient is rendered here. If we want to compare this to a JSON format, well, it's the same data, you're just changing the format. So instead of nice angle brackets, you've got the JSON curly braces and so forth. But all the data is the same. The interesting thing about JSON is that because JSON is a little bit more loose in terms of the structure, you can actually mix and match where things appear in JSON. Although I would highly recommend that you try to stick with the structure that you see here, just to make your life as a developer a little bit easier. So as an example of resources, what are some common types of resources that we'll find in the FHIR specification? Well, in the FHIR spec, we group them into various concepts, if you will, administrative, clinical, infrastructure, and so forth. This is a very, very small sampling of the types of resources that you'll find. What's more important is, what are non-examples? What doesn't count for a resource type? Well, something too small, like an element or an attribute, like gender. Something that's too big, like the electronic health record itself, which is a collection of multiple resources. Blood pressure, well, that's a very specific thing. It's probably an observation, but a very specific type of observation. And intervention, again, probably too broad in terms of concept, so that, again, a collection of different resources pulled together. There are some key resource types in the specification that help you as an implementer or developer, and for those that are going to interact with your FHIR system. The capability statement is one such type of resource. This documents the capabilities that your FHIR system, client or server, are going to do. You're going to tell me what you are going to be able to do, what you support. And the capability statement is the way to do that. So it's a key part of the FHIR conformance framework. It's a statement of the features, rules, and behaviors of your system. And it may be used for things like compatibility testing, for code generation, or the basis for conformance testing itself. Very, very key concept here. To call your server a FHIR conformance system, you must publish a capability statement. And there's the link to the spec there as well, too. So as part of the spec, in order to comply with the spec, your system must present a capability statement. Structure definition is another one of those key types of resources that describe things. In this case, it's a resource that describes the structured data definitions and their rules of usage. Every computable, right? All these resources can be pulled apart and rendered in many different ways. You can see, I can show you what the input parameters were. And so this, sorry for the size there, but so there's a parameters resource type in FHIR where I can send in my message other resources like the patient, immunization, and so forth. So I can render that pretty easily. And then I can look at the results, and of course we can all read those results very easily and see exactly what we need to do next, right? Well, that's really not what we want to see. One of the nice things about FHIR is that you can compute the results and render something in a little bit better format that the pediatrician might be able to use. So all the data here that you're seeing is a FHIR resource parameters with all of the pieces in it pulled apart and rendered in something that's actionable by the pediatrician. So just a nice example of FHIR-in-action. Let's go back to PowerPoint. All right, bear with me. There we go. All right. So that was a nice example of FHIR in action. Now, one of the things that I'm particularly interested in is testing. If you want to come to my FHIR testing track later on today and tomorrow, I'll be talking more about this. But as part of the specification, FHIR actually now defines how to test a FHIR system. So to ensure interoperability between applications claiming conformance, a testing framework was established. And it defines a new resource type called test script, and it represents an executable test definition. So I'm particularly happy about that because that's near and dear to my heart. There are many public FHIR servers for testing. Again, Wildfire is one of those, but you can go up to the FHIR wiki and see a complete list. There's more than a dozen publicly available test servers and clients, and I'm probably sure you're going to see more today. As Eval mentioned, there's going to be a document that you can, if you have a FHIR server, go ahead and put it in there. But these are going to be the publicly accessible ones that support multiple FHIR versions, DS2.2, S2.3, even the current CI build as well. And I think I just saw a Fiora tweet that there's now even more FHIR servers that have been added to the public list as well. So now FHIR, as a means of supporting interoperability, supports various paradigms to implement that. So we have things like REST, documents, messages, and services. Well, REST is pretty straightforward, and this is actually the default paradigm you'll see in the FHIR specification itself. Simple, out-of-the-box interoperability leveraging the HTTP protocols for GET, put, post, and so on. So they allow us to define very easily those basic CRUD operations, create, update, delete. But through modifications of the API itself, through the HTTP use of gets and puts and posts, we can do many other types of operations that FHIR defines, like a history, read version, search, patch, and so on. Obviously, this type of paradigm works well when you have the client in control and you have a trust relationship between all parties. Documents are similar to CDA. There's actually a FHIR on CDA initiative that's been going on for quite some time. So doing a translation between CDA document and a FHIR bundle representation of that document. So if you think about it in terms of a FHIR way of defining a document, it's a collection of resources where you put it into another resource type called bundle. So bundle just bundles other resources together. The key element here is that the first resource in the bundle is going to be called a composition, which is just like what you find in the CDA header. It provides a single context, and that of course then means it can be signed, authenticated, and so forth. Messaging, similar in nature, but again following things like the V2, V3 type of paradigm of messaging, we also collect resources into a bundle. But now instead of a composition, we have as the first resource in that bundle a message header that defines what that message is. It allows for that request-response behavior, managing payloads and so forth. It's event-driven, so think of like that lab report that I mentioned earlier. We're going to send a request for a lab. We're going to get a result back and a response, which is a payload of the report itself, diagnostic report. Can be asynchronous. Part of the FHIR specification is an asynchronous paradigm for doing messaging. So in this particular case, the request would get an acknowledgement back, and that ACK would just be a simple 200 response HTTP response code, right? And then the server, when it's going to fulfill that request, will send a request to the original calling system, and then the calling system would simply do an acknowledgement back. Typically not what we see right now in a lot of FHIR implementations, because there's some things that need to be kind of worked out in an asynchronous paradigm like that, agreements between partners on protocols, responsibilities. You're going to see a lot more synchronous as a default way of doing things. Service-oriented architecture, well, here we're really talking about a combination of all of the above. So if you think about it, we could have very ultra-complex workflows to simple workflows where we're dealing with individual resources or collections of resources, both as bundles or contained resources and so forth. We're going to use HTTP typically, but probably anything else, like secure web sockets, SMS, and so on. The real thing that is important here is that the paradigm isn't nearly as important as the fact that you're passing around FHIR resources. The content is really what is important here. So you can think of a FHIR repository where I've got my data that I'm storing, maybe in native FHIR format. I've got a lab system where I'm going to be sending a FHIR message, and that FHIR message is going to be probably the diagnostic report where my FHIR repository would store that along with any other resources that were part of that report. Remember the little diagram there of patient, related person, and so forth. Well, that data now becomes available. So I might have a clinician on the floor of some hospital with a personal device, and they can do FHIR requests into the repository to get the updated data that might have been sent in. We can aggregate that data into a FHIR document and send it off to a national exchange if we want to, like a discharge summary and so forth. Okay, the FHIR specification. This is where I live, for the most part, is the website for the FHIR specification. And how many people have been to the FHIR specification site? So, most of you? Excellent. So, hopefully I'm preaching to the choir here, you've already seen some of this stuff. But you'll know that there are various versions of FHIR available. And there's the directory page, which gives us those lists of FHIR versions. And you can see there's actually quite a number of them. You might think DSTU2, STU3, and the latest R4 CI build, that's it. Well, you'll notice there's some intermediate releases that have been done here as well. And the reason for those is more for the HL7 FHIR Connectathon events that have been going on. A lot of times, for those Connectathons, they want to try out new features that are going to be built into the spec when it becomes the official version. So Graham will go out and actually publish intermediate versions for FHIR Connectathons. Not every FHIR Connectathon, but a lot of them. And so you'll see things like a 1.4, 1.6, and so forth leading up to STU3. You'll note the version number there. Why isn't that a 2. something for DSTU2? Well, that was just an internal versioning number that we corrected to make 3 to match up with STU3. So don't worry about the internal version number so much. Typically, you're going to be spending a lot of time just with the official version, and you'll notice the official version is at the top of each sequence of versions there. So you want to go to the top one there, the April 19, 2017 3.0.1, and that's the official STU3 version. Likewise, up at the very top, you'll have the current version. So STU3 is current at the top. And then if you want to go to the current CI build, and so that's what R4 is going to become. Okay, so Graham, I believe, is actually talking right now about new features that are going to be coming in R4. And so that's going to be very interesting to look at as it evolves. But the FHIR specification, the home page that you're going to land on, you're probably familiar. You've all raised your hands, so you know what this looks like. I just want to shout out a few different parts of it here. Again, when you're first developing a FHIR system, you're going to spend a lot of time looking at the FHIR API and probably resource types and data types. And I had to shout out on testing there as well too. So if you want to find the testing framework, there's a link to that as well too. But let's take a look at the RESTful API. So on this particular page, you've got different operations or interactions that cover different levels, which is instance, type, and whole system, or what we call global. At the top of the page, you're going to have links to what those operations are. So you'll have read, vread, update, and so forth. Everything is linked here, so you just click on it, and it will drill down into the specification for that. Like update, it'll show you all the requirements that you as a developer need to know when you're building your client or your server to be compliant with the FHIR specification. What HTTP response codes are required based on certain conditions, what HTTP headers, what's the payload, and so on. Looking at resource content, let's go back to the patient resource. If you open up the patient resource page, you're going to find the content of that patient as it's defined, and by default, you're going to fall on this tab called Structure, which is in the middle of the page. And this gives you the hierarchical view of how the elements within the patient resource are arranged. And so here, this is typically where I end up, because I just like to look at things this way. But you can also look at UML, you can look at the XML rendering, JSON, and so forth. But the key thing that I'm pointing out here is that every element has a data type. And the data types in FHIR are all FHIR data types, even though you see something like Boolean there. Well, under the covers, that's really a FHIR data type. So if we were to drill down, link into different data types, we can see the data type page here, where we have primitive data types and complex data types. Again, look at the structure here. Every single data type is derived from a root definition called element within FHIR. So that's why even the data types themselves can be extended. So you remember the extension that you can do on a resource? You can actually do extensions on individual elements within the resource. So you can extend data types as well. You'll notice that complex data types, well, those are really just structures. So unlike a Boolean, which is just going to be a true false, or an integer, which is a numeric, a complex data type like codable concept will link you to another structure definition, where it expands out and you can see what the elements within that structure is. Now, another key concept with FHIR is this whole idea of the FHIR maturity model. The FHIR maturity model is the thing that is used now in FHIR to track when something is going to go normative. So how many people know that R4 is going to have normative content? Okay? So currently right now, what's planned for the R4 release, and everybody's all abuzz about it, is going to go normative. Well, be careful, it doesn't mean R4 as the whole spec will be normative. Various components within the FHIR specification have a maturity model, or assigned to them. In this particular case, we're looking at the resources. So resources like capability statement, structure definition, patient, and so forth, will all have a little number after them. Well, what does that number mean? Well, you can link to it, you can click on it, and it'll actually give you this list of definitions. Now, I've done a little bit of concise editing here, but generally, a 0 means that it's a draft resource. Somebody came up with a great idea for a new resource type, put it into the specification, and it built with no compilation errors. So I should actually put a little extra thing there by draft, no compile errors in the spec. Well, it's no good unless somebody actually starts to use it. And so to move up to the next levels, you can see that there's more and more requirements as they go along for usage. Well, the next step is no build warnings. And then look at number 2. You actually have to bring it to a connectathon, an HL7 FHIR connectathon, where people start to use it. Build prototype applications, start to exchange data with it, and so on. And as you keep moving up the maturity model, you'll notice that by the time you get to 5, you've had to meet quite a few requirements. 5 is the precursor to normative. So look at the FHIR specification and look at the resource types and note how many are currently at level 5. Those are the ones that are most likely going to be going to go normative, or 6, when we go to R4. So just something to keep in mind as you look at the FHIR specification and what you might think of in terms of normative content. The whole spec isn't going to go normative, which is kind of a little bit different concept than what we're used to with V2 and V3 and so forth. So just something to keep in mind. So, in terms of FHIR, what does FHIR give us? Well, the definition of resources and resource types as building blocks upon which we're going to build our FHIR systems. Extensions are part of the specification. Methodologies for transport of that data, collecting it, bundling it, and so forth. There's conformance built in, there's testing built in, and all these other different ideas and concepts that have been baked in. The syntax, XML, JSON, Turtle, and so forth. Human readability, just like with our CDA documents, very important concept, so that's there. The conformance type of resource types, capability statement, structure definitions. Multiple paradigms that are supported for the exchange of data, and of course extensive online documentation. So this is just a whirlwind tour to give you a brief glimpse into some of the things that FHIR provides for us. And one of the things that I wanted to kind of end with here is, what's the FHIR timeline look like? So FHIR started way back in 2011. And this was a concept between Graham and Ewout and Lloyd McKenzie, I believe. Josh came in very early in that as well too. I see Josh sitting in the audience. Shout out there. But by the time we got to 2013, 2014, we'd had our first version, 1.0. So Draft Standard for Trial Use. That's what DSTU stands for. When we got to 2015, we ended up with DSTU2. And now we're at STU3. Notice the D got dropped because it's no longer draft. So it's still a standard for trial use, but they got rid of the draft. And now the nomenclature is going to be going towards release versions. So that's why we're going to the term R4. And even today you'll hear Graham talk about R3 and R2. So the concept of DSTU2 or STU and so forth, he wants to kind of, let's push that down now. We're talking about releases of FHIR because we're at that point. And as I've mentioned, R4, coming out later next year, is slated to have our first normative content. So with that, I want to thank you. And how are we doing on time?
You still have 10 minutes.
Still 10 minutes. So I actually have time to open this up for any questions, comments. So if anybody has anything they'd like to ask. Anyone? Okay. Yes? I'm going to have to come closer. Encryption. So does the standard talk about encryption? One of the aspects about the FHIR specification you'll probably notice is that the security layer, although we have resource types for security, we've got provenance and so forth. Security and things like encryption are things that are outside the spec, because those are things that you apply to an implementation, right? So how you're going to transfer it. So if you want to use HTTP, well, that's probably not very secure, right? You want to use HTTPS with SSL certificates, you want to use TLS, so that's going to be part more of how you exchange that data from one system to another. So you're going to have to come up with an agreement for whatever environment that you're going to be in. So the FHIR spec doesn't dictate or say how to do encryption. They recommend that it's something you probably should do. Does that help? We can talk soon. Yeah. Anything else? Any other questions? Yes? Right, so the immunization forecast use case, so analytics, here you're talking about the clinical decision support type of aspect. So there's actually a whole part of the specification that they're currently working on. They're going to be incorporating something called CDS hooks into the specification. I know that Josh Mandel with Smart on FHIR, that paradigm as well too, has come up with a standardized way of doing interfaces and so forth with security as part of that specification, OAuth 2 and so forth. So from a clinical decision support perspective, I would probably go take a look at the CDS hooks, and there's also other things that you could look at as well. Like the FHIR Connectathon events as well have different tracks, and I know clinical decision support has been a big one. And so there's a lot of resources. Bryn Rhodes is actually quite involved with that, so I would probably recommend that you talk to Bryn. He'd probably be able to talk better to that. Okay. Mm-hmm. Anybody else? Yes? Yes.
Immunization forecasting service that you showed.
Mm-hmm.
FHIR resources in and returned collection results. So is that considered a quote-unquote FHIR service, or is that just one that understands
So,
FHIR?
so it was interesting. So for the implementation guide for this, because when I started working with Nathan on this, we were at San Antonio Connectathon 11. Okay, I'm trying to remember. No, it was actually earlier than that, 9. But he had been working with the CDC and the Immunization Information Systems group, and he wrote a little forecast engine for testing. That's actually what I was using. It's not a real forecast engine like from the CDC. It's his test forecast engine that he wrote, because that's publicly accessible. But we looked at it and said, well, how could we build something in FHIR that is conformant to FHIR, but something new, right? So what paradigm do we use? And we knew that FHIR defined FHIR messaging, right? But we also had operations as well. So FHIR actually defines what's called an operations framework. So you remember the operations we have, you know, the CRUD operations, the history, the vread, and so forth. Those are all standard operations. But FHIR in the specification also defines an operations framework. And if I have, do I have a few minutes still yet? Okay. Let's run to the FHIR specification itself. And let's go to documentation. There we go. And operations. So there's this thing called extended operations that, again, built on the RESTful API. The extended operations provides a framework for, you know, doing things above and beyond. Okay. So FHIR messaging really hasn't taken off in terms of a paradigm as well as we might think, because actually we have this. And so we started to leverage doing this with a forecast operation. So the framework itself defines, remember I showed you the content of the payload, you know, so the request response, they were all contained in something called a parameters resource. Like a bundle, parameters is a way to collect resources, but even more so. It's in that terms of what parameters do I want to collect for this operation. Because I can't just put it on the URL, you know, for the request. So I have to have a payload where I can put in primitive data types, complex data types, FHIR resources, you know, and so forth, for inputs and for outputs. So we started doing that as an approach. So our first implementation for the forecast is as an extended operation where we parameterize everything. And so that was the paradigm that we chose. We are looking at CDS hooks integration with the forecast that we're going to be doing. But we wanted to get this out there first and standardized, and then we're going to be actually looking at CDS hooks next, how to integrate a forecast with CDS hooks, which kind of talks to our question over here on clinical decision support. So does that help? Okay. I saw one other question over here. Yes.
So can you share about the trend of adoption in real clinical applications? Like, is there any now or like the forecasting like in the near future? How will it be like?
Well, I can talk to immunization forecast again because that's what I'm kind of working on right now. But yeah, the FHIR implementation of the forecasting. So let's see. So there is a collaborative collection of people that are actually working on this, and we are going to be promoting this as the interface now for standardizing for all the forecast engines that are in the US. But they've actually taken a look at it and said, well, how can we do this from an international perspective as well, too? So they've been hashing through the parameters, and we started out with just the simple parameters that you saw there, patient immunization, but now you've got assessment date, you've got other concepts like we can pass in observations that represent things that have occurred in the patient's history that may feed into the forecast as well. So the definition has been expanded a bit based on what we initially started with, but that should hopefully be balloted in the January timeframe for inclusion as a real implementation guide with the FHIR spec, and then they're going to start pushing that out in terms of this is how you can start implementing. So the forecast engines will still do what they do with their proprietary interfaces, but now they'll build this FHIR interface as a standardized way. So the nice thing about that is if I want to go to a forecast engine today, I got to know the interface, right? So I could have different client interfaces depending upon the forecast engine, but if we do this, I need to only have one client that can talk to any one forecast engine that has the standard interface. So hopefully by later next year, we should start to see that happening. In terms of other things that are going on that are real world, I don't have probably as much to offer in terms of knowledge right now, but I'm sure there are many other people here. I know FHIR, you've been working especially here in Finland and so forth, so there's a lot of work going on. New Zealand is very active in trying to promote FHIR as their main way of interfacing with their clinical systems, so they're kind of pushing where we're going with that as well. Okay? Okay. I think we're good.
Yeah.
We're at 9:40.
Yes.
Okay. So I can take the question offline. Okay. All right. Well, thank you, and welcome to DevDays.